For millennia, across countless cultures, the morning star has commanded our gaze. That brilliant beacon, piercing the twilight sky, was not merely a distant point of light. It was a canvas for humanity's grandest aspirations, a celestial mirror reflecting our deepest desires for other worlds. It was Venus, shrouded in mystery, yet bursting with the promise of life, a utopian dream spun from the ethereal glow of dawn and dusk. For centuries, our closest planetary neighbor, nearly identical in size and mass to our own Earth, lingered as an enchanting enigma, a sister world surely teeming with verdant landscapes and perhaps even intelligent civilizations, just beyond the veil of its perpetual clouds. This romanticized vision wasn't solely the product of poets and philosophers. It was, paradoxically, fueled by early scientific inquiry. During the 17th and 18th centuries, as telescopes grew more powerful, astronomers began to pierce some of Venus's secrets. One pivotal moment arrived in the year 1761, during a rare transit of Venus across the Sun. From a remote observatory in Russia, the polymath Mikhail Lomonosov, observing the planet's silhouette against the solar disk, noted a peculiar luminous ring around its edge. This breathtaking optical phenomenon was correctly interpreted by Lomonosov as irrefutable evidence of a substantial atmosphere surrounding Venus, a groundbreaking discovery that only solidified the burgeoning belief in a potentially habitable world beneath those clouds. If Venus possessed an atmosphere, the reasoning went, surely it must have water, and where there was water, life could flourish. This potent cocktail of scientific observation and optimistic speculation permeated popular culture. Writers of early science fiction, unburdened by the stark realities we now understand, painted vivid pictures of Venusian paradises. Consider the captivating narratives crafted by authors like Edgar Rice Burroughs, whose Amtor series transported readers to a vibrant Venus, a world of lush jungles, exotic creatures, and heroic adventures. These stories, read by millions, firmly cemented Venus in the collective imagination as not just a possible home, but an accessible, almost familiar destination, ripe for exploration and, perhaps, colonization. It was a golden age of interplanetary dreams, where Venus stood as the ultimate symbol of hope for discovering life beyond Earth, a shimmering promise in the vast cosmic ocean. Then, the dream shattered. On December 14th, in the year 1962, a new kind of explorer embarked on an unprecedented journey, the Mariner 2 probe, a robotic envoy from NASA's Jet Propulsion Laboratory in the United States of America. This audacious mission, designed to be the very first successful planetary flyby, was sent not to confirm our romantic notions, but to gather cold, hard data. As Mariner 2 swept past Venus, just over 34,000 kilometers from its surface, its instruments began to transmit back information that would irrevocably alter our perception of Earth's closest neighbor. The data was not merely surprising, it was terrifying. The probe's microwave radiometer, peering through the perpetual cloud cover, detected surface temperatures so extreme they defied the optimistic predictions of decades. The readings indicated a scorching heat exceeding 425 degrees Celsius, or more than 800 degrees Fahrenheit. To put that into perspective, this temperature is hot enough to melt lead, zinc, and even some types of glass. This wasn't a lush jungle world. It was an inferno. The revelation was a seismic shock, a brutal scientific reality that replaced centuries of hopeful conjecture. It was the first chilling clue in a cosmic murder mystery, an undeniable sign that something catastrophic had happened to our once beloved sister planet. The psychological and cultural impact of this discovery was profound. The morning star, once a symbol of utopian possibility, had been unmasked as a planetary-scale catastrophe. Venus, the twin, the sister, had transformed into a vision of hell. The question that emerged from Mariner 2's terrifying data became central to planetary science. How could a world so similar to our own in size and composition, once considered our greatest hope for extraterrestrial life within the solar system, have devolved into such a nightmarish cautionary tale? This initial glimpse into Venus's brutal reality transformed it from a fantastical destination into a dire warning, setting the stage for a decades-long investigation into the death of a dream and the chilling secrets of a world turned utterly hostile. The inferno of Venus, revealed by Mariner 2, was just the symptom of a profound planetary illness. To truly understand the disease that ravaged Earth's sister, transforming her from a utopian dream into a cosmic nightmare, we must delve deeper into the very heartbeat of a world and the missing shield that left it utterly exposed. For billions of years, a crucial defense mechanism, one fundamental to life as we know it, has been conspicuously absent on Venus, setting the stage for its agonizing demise. The first clue to this systemic failure lies in an often overlooked, yet utterly bizarre, characteristic: Venus's rotation. Consider for a moment the very foundation of a living planet. Beyond its composition and its distance from a star, a planet's spin is paramount. This isn't merely about the length of its days. It is about the fundamental mechanics that allow a world to generate its own protective bubble in space. Deep within a planet's core, where molten iron churns under immense pressure, the rotation of the planet itself helps to drive a powerful phenomenon known as the dynamo effect. This process creates a global magnetic field, an invisible but vital shield that deflects the relentless onslaught of charged particles streaming from the sun, particles collectively known as the solar wind. Without this shield, a planet is naked, vulnerable to the harsh radiation of its star, a cosmic battering ram constantly tearing away at its atmosphere. Now, turn your gaze back to Venus. While Earth spins rapidly, completing a full rotation in just 24 hours, Venus moves at a glacial pace. A single Venusian day lasts for an astonishing 243 Earth days. That means a day on Venus is actually longer than its year, which clocks in at a mere 225 Earth days. If that wasn't strange enough, Venus also rotates in the opposite direction to most other planets in our solar system, a phenomenon known as retrograde rotation. It spins backwards, like a cosmic rebel moving against the flow. How could a planet so similar to Earth in size and mass end up with such a confounding and lethargic spin? For years, this anomalous rotation remained a perplexing puzzle. Then, in the early 2000s, astronomers like Alexandre Correa and Jacques Lascar, working out of France, began to piece together a compelling hypothesis. Their research suggested that Venus's bizarre spin wasn't an inherent trait, but rather the result of a traumatic event, or perhaps a series of them, in its distant past. One leading theory points to a history of giant impacts, colossal collisions with other massive celestial bodies early in the solar system's chaotic formation. Such a titanic impact could have been powerful enough to not only dramatically slow Venus's rotation, but even to flip its axis entirely, setting it spinning in the reverse direction. Another hypothesis involves complex tidal interactions with the Sun, a gravitational tug-of-war over billions of years that gradually sapped Venus's rotational energy, grinding it to a near halt and eventually flipping its orientation. This wasn't just a quirky planetary detail, it was a critical vulnerability, a profound impairment to its very planetary defenses. The connection between this crippled rotation and the absence of a global magnetic field is direct and devastating. For the dynamo effect to effectively generate a robust magnetosphere, a planet typically requires a relatively rapid and consistent rotation. Venus's agonizingly slow and reversed spin simply cannot generate the necessary forces within its molten core to create a powerful global magnetic shield. The liquid metal within Venus's interior might be churning, but without that crucial rotational momentum, the currents cannot organize into the coherent, planet-spanning magnetic field that safeguards Earth. This vulnerability has had catastrophic consequences for billions of years. Data from missions like ESA's Venus Express, which orbited Venus from 2006 to 2014, provided stark evidence of the relentless assault. Without a magnetic field to deflect it, the solar wind, a supersonic stream of energetic particles, continuously slams directly into Venus's upper atmosphere. The mission's instruments meticulously tracked how these high-energy particles strip away lighter elements, particularly hydrogen and oxygen, directly from Venus's atmospheric layers, effectively bleeding the planet dry of its most crucial components. It is as if a cosmic thief, unimpeded, is slowly siphoning away the very building blocks of a habitable world. This, then, is the 1-2 punch that dealt a crippling blow to Earth's sister planet. A traumatic event in its distant past, perhaps a cataclysmic impact, crippled its rotation, transforming its spin into a sluggish, backward crawl. This, in turn, dismantled its planetary defenses, leaving it utterly exposed and vulnerable to the harsh solar environment. For billions of years, the Sun's relentless winds have slowly but surely stripped away the lighter, more volatile elements from Venus's upper atmosphere, a crucial precondition for the hellscape we observe today, paving the way for an even more profound transformation. The raw vulnerability of Venus, its missing magnetic shield laying bare its atmosphere to the Sun's relentless assault, set the stage for unimaginable horrors. But the final, catastrophic blow, the event that truly sealed its fate as a planetary hell, came not from the Sun, but from within. We must now turn our gaze to the prime suspect in Venus's demise, a period of unimaginable planet-engulfing volcanism. To truly grasp the scale of what may have happened on our sister planet, we must first look homeward, to a time when Earth itself teetered on the brink of total annihilation. Consider the Permian-Triassic extinction event, often chillingly referred to as the Great Dying. This was not just another mass extinction, it was the worst in Earth's history, a cataclysm that unfolded approximately 252 million years ago. Its primary cause is widely believed to be the eruption of the Siberian Traps, a colossal volcanic province in what is now modern-day Russia. For perhaps 1 million years, or even more, volcanoes erupted on a scale that dwarfs anything humanity has ever witnessed, spewing forth literally millions of cubic kilometers of molten rock and, more critically, colossal amounts of carbon dioxide, sulfur dioxide, and other greenhouse gases into our planet's atmosphere. This unleashed a cascade of environmental devastation, acidifying the oceans, depleting atmospheric oxygen, and igniting a global warming event so severe that it nearly extinguished all life on our planet. More than 90% of all marine species and 70% of terrestrial vertebrate species simply vanished. Earth survived, but it was a close call, a stark reminder of geology's immense power. Now, project that terrifying scenario onto Venus. Planetary scientists, notably Michael Way at NASA's Goddard Institute for Space Studies, have put forth a compelling hypothesis. Venus may have experienced a similar, massive, large igneous province event, but on a far, far grander scale than anything seen on Earth. This wasn't merely a few volcanoes erupting. This was the planet's entire surface being remade, inundated by rivers of lava for geological epochs. And unlike Earth, Venus had no vast oceans to absorb the overwhelming deluge of carbon dioxide, no biological systems capable of buffering the climatic effects of such a gargantuan outgassing. The conditions were ripe for a runaway catastrophe, a one-way trip to an uninhabitable inferno. Proof of this cataclysmic past is etched into Venus's very face. For years, its thick, opaque atmosphere obscured its surface from our optical view, a veil of mystery that tantalized and frustrated scientists alike. Then came NASA's Magellan mission, a robotic explorer that orbited Venus from 1990 to 1994. Magellan employed sophisticated radar mapping, essentially using radio waves to pierce through the planet's dense clouds and create a detailed, three-dimensional picture of its hidden terrain. What Magellan revealed was nothing short of astonishing. The surface of Venus is overwhelmingly covered in vast, smooth, volcanic plains, punctuated by countless volcanic structures, immense shield volcanoes, expansive lava flows, and sprawling networks of tectonic fractures. The sheer uniformity of this volcanic landscape across vast regions suggests not a gradual, continuous process, but rather a geologically recent, global resurfacing event. Imagine an entire planetary skin being peeled away and replaced by fresh lava, burying older craters and features. This isn't the slow, steady hum of plate tectonics seen on Earth, where volcanism is localized along plate boundaries. This is evidence of a planet-wide convulsion, a monumental outpouring from its interior that likely released staggering quantities of gases directly into its already thick atmosphere. It reframes the runaway greenhouse effect not as a slow, creeping process that gradually intensified over eons, but as a violent, geologically triggered catastrophe, akin to Earth's worst mass extinction, but with no possibility of recovery. The sheer volume of gases injected into the atmosphere during such an event would have been unfathomable, a toxic cloud of carbon dioxide and sulfur compounds that would forever transform Venus into the searing, desolate world we observe today. If the previous chapters painted a portrait of a world ravaged by internal turmoil and exposed to the sun's fury, the ultimate tragedy of Venus lies in something far more fundamental, something that touches the very essence of life itself, the complete and utter disappearance of its water. Was Venus once a blue world, a true sister to Earth, complete with vast, shimmering oceans? For decades, this question fueled scientific speculation, but today, we have moved beyond mere conjecture. The hard data, gathered from robotic explorers far across the solar system, points to a definitive, heartbreaking answer, etched forever into Venus's scorching atmosphere. How does one trace a ghost ocean, lost to the void over billions of years? The answer lies not in ancient shorelines or fossilized seabeds, but in an almost imperceptible chemical imbalance still present in Venus's incredibly dense atmosphere. The key is found in hydrogen, the most abundant element in the universe, the very building block of water. Most hydrogen atoms are incredibly light, consisting of a single proton and a single electron. But a tiny fraction, about 1 in 6,400 on Earth, is slightly heavier. These are known as deuterium, or heavy hydrogen, an isotope of hydrogen that contains an extra neutron in its nucleus. Think of it like this. If ordinary hydrogen is a tiny, buoyant balloon, deuterium is a slightly heavier balloon, almost imperceptibly so, but crucially, heavier nonetheless. The culprit for this loss is the very star that gave Venus life. Over eons, the sun's relentless ultraviolet radiation relentlessly assaulted Venus's upper atmosphere, shattering water molecules, H2O, into their constituent atoms, hydrogen and oxygen. This process, known as photodissociation, liberates the atomic hydrogen, making it vulnerable. And here, the chain of destruction links back to a critical vulnerability we explored earlier: Venus's missing magnetic shield. With no powerful, planet-spanning magnetic field to deflect the solar wind, that supersonic stream of charged particles hurtling from the sun at speeds of hundreds of kilometers per second, the lighter hydrogen atoms were like feathers in a cosmic hurricane. They were easily swept away into the vast emptiness of space, constantly stripped from Venus's upper atmospheric layers. The heavier deuterium atoms, however, being ever so slightly more massive, were less susceptible to this constant stripping. While some undoubtedly escaped, a disproportionate amount was left behind. This process, repeated over countless millennia, slowly but surely altered the chemical signature of Venus's atmosphere, creating a distinct fingerprint of its profound loss. It is a chemical echo of a once watery past, a silent testament to a world that died of thirst. For decades, this theory remained largely a hypothesis. But then, a groundbreaking series of missions, spearheaded by the Soviet Union in the 1970s and 1980s, provided the undeniable smoking gun. The Venera probes, an astonishing feat of engineering that defied the hellish conditions on Venus, sent back precious atmospheric measurements. These robotic pioneers, some of the only spacecraft ever to land and operate on Venus's surface, or survive long enough in its atmosphere, meticulously analyzed its chemical composition. And what they found was a staggering isotopic anomaly. Venus's atmosphere contained an extraordinarily high ratio of deuterium to ordinary hydrogen. The ratio was found to be more than 150 times higher than that found in Earth's oceans. A truly monumental difference, screaming out a story of loss on an unimaginable scale. This chemical fingerprint tells a chilling tale. It screams that a massive, truly gargantuan amount of ordinary, lighter hydrogen has been stripped away into space over the aeons, leaving behind its heavier cousin. This confirms the powerful narrative chain we have been piecing together. The traumatic events that led to Venus's slow, retrograde rotation crippled its ability to generate a robust magnetic shield. This lack of a shield then allowed the relentless solar wind to easily carry away the light hydrogen atoms, the very essence of its water, effectively boiling entire oceans into the unforgiving vacuum of space. It paints a vivid, heartbreaking picture of a once blue world, dying of thirst, molecule by molecule, stripped bare by its own star. The oceans had vanished, the atmosphere was a crushing, poisonous shroud, and the surface a molten landscape. Yet, the true tragedy of Venus, the reason it remains an inferno, lies not just in what happened, but in what failed to happen. Earth, our own blue planet, possesses an extraordinary self-regulating mechanism, a planetary thermostat that has, for billions of years, kept our climate within the narrow bounds necessary for life. This intricate geological dance is known as the carbonate-silicate cycle, and understanding its elegance on Earth is key to grasping Venus's profound, irreparable breakdown. Consider Earth's remarkable ability to manage its most potent greenhouse gas, carbon dioxide. It begins with rainwater. As carbon dioxide from the atmosphere dissolves into rain, it forms a weak acid called carbonic acid. This mildly acidic rain then falls upon rocks, slowly dissolving or weathering them. As rocks like silicates break down, they release elements such as calcium, which then combine with the dissolved carbon from the carbonic acid to form new minerals, specifically carbonate minerals. These carbonates are essentially carbon dioxide locked away into solid rock, often transported by rivers to the oceans where they settle on the seafloor. But the story doesn't end there. Earth is a geologically active world, driven by the slow, majestic churn of plate tectonics. Over millions of years, the oceanic crust, laden with these carbon-rich carbonate minerals, is subducted or slowly dragged back down into the planet's mantle beneath continents and island arcs. Deep within Earth's fiery interior, the intense heat and pressure cause these subducted rocks to melt, releasing the trapped carbon dioxide once again, often through volcanic eruptions. This completes the cycle, a grand loop that continuously pulls carbon dioxide out of the atmosphere, stores it in rocks, and then slowly releases it back, maintaining a delicate, long-term atmospheric balance. This is Earth's planetary thermostat, a slow but incredibly effective regulator of global temperatures, ensuring that even significant changes in atmospheric carbon dioxide are eventually buffered. Now, turn your gaze back to Venus, a planet with a thermostat that shattered beyond repair. Without liquid water, the very first indispensable step of Earth's crucial carbonate-silicate cycle becomes utterly impossible. There is no rainwater to dissolve atmospheric carbon dioxide, no carbonic acid to weather rocks, and therefore no way for carbon to be directly locked away into carbonate minerals. The vast quantities of carbon dioxide that choked Venus's atmosphere, likely from a period of massive volcanic outgassing, had no pathway out, no mechanism to be chemically sequestered from the air. Furthermore, evidence from NASA's Magellan mission, which mapped Venus's surface from 1990 to 1994 using radar, strongly suggests that Venus lacks Earth-style plate tectonics. Unlike Earth's fractured crust, which is divided into constantly moving plates that subduct and recycle material, Venus's surface appears to be a single, relatively unbroken lithosphere. This means there is no efficient mechanism for burying carbon into its crust and mantle. On Earth, plate tectonics is the ultimate carbon sink, a geological conveyor belt that removes carbon from the atmosphere over geological timescales. On Venus, that crucial system is missing. The massive volcanic outgassing event, a planetary-scale convulsion that transformed Venus's surface, was a one-way ticket for its climate. Carbon dioxide, sulfur dioxide, and other gases were pumped into the atmosphere in staggering quantities, with nowhere to go. This created an inescapable feedback loop. More greenhouse gases meant hotter temperatures, which meant any residual water vapor boiled off, further preventing any possibility of a carbon cycle. The planet became a closed system for carbon, trapping it in its crushing atmosphere. Today, 96% of Venus's atmosphere is carbon dioxide, a stark testament to a broken planetary system. This provides a deeper, systemic reason for Venus's infernal state, moving far beyond the simple concept of a greenhouse effect, to explain the catastrophic failure of an entire planetary system to self-regulate. We have journeyed through Venus's catastrophic past, witnessing the slow suffocation of a sister world, a planetary tragedy born of a missing shield, lost oceans, and a broken thermostat. But what if the crime scene we have so meticulously investigated, the one we have come to see as a static planetary tomb, still pulses with a terrifying, fiery life? What if, after billions of years of infernal torment, Venus refuses to lie dormant, continuing its geological dance in ways we are only just beginning to comprehend? Our investigation into this hellish world is far from over. Indeed, the most surprising revelations about Venus are emerging from the very depths of its present, treating this scorching planet not as a dead relic, but as an active, dynamic laboratory. For decades, the conventional wisdom held that Venus was geologically inert, a planet whose internal heat had long since dissipated, leaving its surface frozen in time after its cataclysmic resurfacing. Yet, recent discoveries, pieced together from sophisticated orbital missions, are challenging this long-held belief. One of the most compelling clues points directly to ongoing active volcanism, a tantalizing whisper of a subterranean inferno still churning beneath the planet's thick clouds. For instance, data from ESA's Venus Express orbiter, which diligently circled Venus from 2006 to 2014, revealed localized hotspots on the planet's surface. These aren't just random temperature anomalies. They are specific regions exhibiting higher infrared emissions, suggesting recent lava flows that have not yet cooled to the ambient, albeit still scorching, surface temperatures. It is as if the planet is revealing tiny, glowing wounds, fresh from a recent geological upheaval. Further evidence for this ongoing activity comes from the planet's oppressive atmosphere itself, specifically through the inexplicable fluctuations in atmospheric sulfur dioxide levels. Sulfur dioxide is a particularly volatile gas. When exposed to the relentless solar ultraviolet radiation at Venus's cloud tops, it breaks down remarkably quickly, decaying in a matter of days or weeks. This means that for sulfur dioxide to be consistently present in Venus's atmosphere, and for its levels to show noticeable increases, there must be a constant, active source replenishing it. The most plausible culprit for such a sustained emission is active volcanism, deep below the clouds. Imagine a vast planetary exhaust pipe continually belching out fresh gases, an undeniable sign that Venus's internal engine has not yet sputtered into silence. Yet, active volcanism is not the only enigma that makes Venus a living mystery. High above the scorching surface, in the planet's upper cloud decks, lies another profound puzzle, one that has baffled scientists for more than 60 years, the enduring mystery of the unknown ultraviolet absorber. This mysterious substance, whatever its nature, has an extraordinary capacity to absorb an astonishing amount of solar energy. Nearly half of the sun's radiation reaching the planet is simply consumed by this unseen agent. First detected and puzzled over by visionaries like Carl Sagan and his colleagues in the 1960s, this absorber casts an omnipresent shadow, playing a fundamental role in Venus's extreme heat balance, yet its identity remains elusive, a chemical ghost in the machine. What could this enigmatic absorber be? Scientists have put forth a range of hypotheses, some purely chemical, others venturing into the realm of speculative biology. One line of thinking suggests complex chemical cycles involving sulfur compounds or even exotic allotropes of carbon, substances capable of reacting with ultraviolet light in unexpected ways within the unique chemistry of Venus's atmosphere. The conditions are certainly extreme. Temperatures can reach 100 degrees Celsius, or 212 degrees Fahrenheit, within these clouds, with pressures 50 times greater than Earth's sea level. But there is another, far more provocative hypothesis that has steadily gained scientific traction: the possibility of airborne microbial life. Biochemist Harold Morowitz, among others, has proposed that despite the planet's hellish surface, the temperate cloud layers at altitudes between 50 and 60 kilometers, or 31 to 37 miles, could offer conditions where extremophile microorganisms might thrive. These microscopic life forms, if they exist, could be absorbing the ultraviolet light as a form of energy, using it to drive their metabolic processes, much like photosynthetic organisms on Earth use sunlight. This radical idea transforms our perception of Venus even further, suggesting that life, in some form, however alien, might have found a refuge in the only potentially habitable niche left on the planet. The implications are profound, pushing the boundaries of what we consider a habitable environment. This ongoing investigation highlights that Venus is not merely a cautionary tale from the past, it is a dynamic, evolving world with secrets yet to be uncovered. Indeed, the scientific community is rallying once again to pierce Venus's veil. A new generation of sophisticated missions is currently being prepared to embark on this audacious journey. NASA's Veritas, or Venus Emissivity, Radio Science, INSAIR, Topography, and Spectroscopy mission will use cutting-edge radar to create high-resolution maps of Venus's surface, seeking out definitive signs of ongoing geological activity and perhaps uncovering the composition of its ancient, hidden crust. Simultaneously, NASA's Da Vinci I+, or Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging Plus, will deploy a probe directly into Venus's crushing atmosphere, sampling its chemical composition at various altitudes to unravel the mysteries of its formation and evolution, and perhaps even find clues to the UV absorber. Not to be outdone, ESA, the European Space Agency, is planning its own ambitious mission, ENVISION, which will use advanced radar and spectroscopic instruments to study Venus's atmosphere and surface, providing an unprecedented global view of its geological and atmospheric processes. These upcoming missions promise to peel back further layers of mystery from Earth's hellish sister, confirming that even a world so utterly transformed still has profound, crucial lessons to teach us about planetary evolution, the resilience of life, and perhaps the very nature of habitability itself. We have journeyed through the searing plains and crushing atmosphere of Venus, tracing the death of a dream and the birth of a nightmare. Our investigation into Earth's enigmatic sister planet has revealed not a simple tragedy, but a cosmic murder mystery, where the culprit was not a single catastrophic blow, but a devastating cascade of unfortunate events. To truly understand why Venus became hell, we must now piece together these clues, allowing the planet itself to whisper its profound verdict. The story of Venus's transformation is a chain reaction, a perfect storm of planetary misfortune that started billions of years ago. It began with its genesis, a potentially traumatic birth or early history that fundamentally altered its very spin. That initial cosmic ballet left Venus with a bizarrely slow, backward rotation, a planetary waltz that took hundreds of Earth days to complete a single turn. This sluggish, retrograde movement was no mere curiosity. It was a critical vulnerability, for without a relatively rapid and consistent spin, the dynamo effect deep within its molten core could not generate a powerful, planet-spanning magnetic shield. This lack of a protective magnetosphere, an invisible bubble that deflects the sun's lethal solar wind, left Venus utterly exposed. Over eons, the relentless stream of charged particles hurtling from our star at hundreds of kilometers per second began its slow, merciless assault. It systematically stripped away the lighter elements from Venus's upper atmosphere, specifically the hydrogen. The telltale sign, etched into the planet's very breath, is the extraordinarily high ratio of deuterium to hydrogen, a chemical fingerprint screaming that entire oceans, once vast and shimmering, were boiled away into the unforgiving vacuum of space. Then, as if the loss of its water were not enough, another cataclysm struck from within. Evidence suggests a period of unimaginable planet-engulfing volcanism, a monumental outpouring of molten rock and gases that dwarfs anything seen on Earth. One might think of our own planet's Permian-Triassic extinction event, the Great Dying, triggered by the Siberian traps, which nearly extinguished all life. But Venus's volcanic convulsion was on a far grander scale, spewing unfathomable quantities of carbon dioxide and other greenhouse gases into its already dense atmosphere. And here lies the final, most devastating blow. Unlike Earth, Venus had no mechanism for recovery. Without liquid water, the essential first step of our planet's carbonate-silicate cycle, that miraculous long-term climate regulator, was impossible. Carbon dioxide had no way to dissolve into rainwater, weather rocks, and be locked away into carbonate minerals. Furthermore, Venus appears to lack Earth-style plate tectonics, that magnificent geological conveyor belt that buries carbon into our planet's crust and mantle. The massive volcanic outgassing was a one-way ticket. The carbon dioxide, the suffocating blanket, had nowhere to go, trapping Venus in an irreversible greenhouse state, a broken thermostat forever stuck on Inferno. The ultimate takeaway from Venus's tragic story is not a prophecy that Earth is destined to share its fate, but a far more profound lesson about the nature of planetary habitability itself. Venus serves as a cosmic mirror, reflecting back to us the incredible fragility of our own blue world's equilibrium. It reveals how a planet so similar to our own in size and composition, indeed, Earth's twin in so many fundamental ways, can be pushed past a tipping point by a series of unfortunate, yet entirely natural, events. It underscores the delicate, intricate balance of geology, biology, and atmospheric chemistry that allows life to thrive here. Venus is a humbling reminder that our planet did not just emerge, it won a cosmic lottery, a precisely tuned set of circumstances that allowed it to remain a verdant oasis while its sister transformed into a perpetual hell. The secrets of Venus continue to unfold, a chilling cautionary tale written in fire and acid rain, offering invaluable insights into the forces that shape worlds and the precious, fleeting nature of life's foothold in the vast, indifferent cosmos.